Good evening, Dr. Vera.
Good evening, Sir Jonas. We will wait for, let's say, 5 minutes for the rest of the students that might be joining. Yeah, for
Good
those of
evening,
you,
Doc.
good evening, Mr. Kenneth. For those of you that just joining today's sessions, you're welcome. This is our second meeting for the Advanced Optimization Technique class. So in our first meeting yesterday, we did already discuss the overview of the whole courses as well as the first week materials. Okay, we do have some introductions to know each other and also the setup of the class, like what kind of assignments that you will have and how I will conduct the rest of the class for the remaining time that we have. Okay, so if you're just joining today, I would like to recommend to see the recording of our previous meetings. So if you are wondering where you can see the recording, I did upload it on the Blackboard learning management system, as well as in the Facebook group, so that you can have access. So basically, the video is uploaded to YouTube because I think that one is the one of the most ready platform to like stream the recording well, because it's quite long, so that you can have a more comfortable way to see the recording. So if you want to fast it forward, adjust the speed, including to make sure the connection, I think YouTube is a good platform to be used. All right. So also regarding to the assignment and task, I think I did see like some of you already start doing the quiz, especially the first quiz, which cover module 1 until module 4. So thank you very much for your hard works and attentions to this course. And for those of you that doesn't able to do it yet, don't worry, because you have time. I think I set the deadlines up until end of this week. But again, if you have somehow under circumstances that you will not be able to complete it by the end of this week, please let me know. Okay. The hard deadline will be somewhere before submitting the grades to the registration office. Okay, so now I think several students already joining. Let me try to share my screen. Share screen, and yeah, this one share. Yep. So I will direct screen here. Or maybe before going to these slides, let's go to explore this one. Yeah. Okay. So things that I mentioned earlier is that the quiz, which is here. So if you go to this particular quiz, that will cover material 1 in module 1, module 2, module 3, module 4. I know that I have not yet um, um, discussed the details of each modules, but this class was designed to be asynchronous, right? So you will have more flexibility on your side according to the free times that you have. So with that in mind, That's why I try to upload the materials first, even before we're having time to discuss about it. Yeah. Some material even like you can find other sources in the internet, in the YouTube discussing the same thing. Okay, so that's why it is very, very flexible if you want to do it the quiz even before the courses or the materials was catching up. Um, Meanwhile, it also great even if you don't do the um what if you are even not yet even finding any materials, you just want to test your base understanding because yeah, like this quizzes was designed to be having multiple even unlimited attempt so that when you failed the first time you can use it as a okay, I know what kind of things I need to understand from those module. There, when you start to learn about it, you start exploring the PowerPoints that I upload, you start exploring materials from the books that I refer to, and even when you attending the class, which is like I will try to do it every day, you already have things in mind to be like discussed or to be cross-check or validate. Okay, so that's the way I designed the courses for those of you that hasn't joining in the previous sessions in the first sessions. Okay. Okay, now let's start. I think this is being recorded already, right? Yeah, yeah, but I think that will be in the cloud. Yeah, that's okay. We can try. So now we have discussed about this one, right? Last time, module 2. Where we see the optimization techniques, especially the second part. So we do have optimization technique part 1, which is another courses, talk about mathematical modelings, talk about formalize the problems, optimization problems into its mathematical form, and then trying to solve it uh, using analytical approach. So the optimization techniques too put more emphasis on where the complexity of the problem where will be increased when you consider uncertainty in the problems that you're going to discuss or you're going to solve. Uncertainty could lead to several things, such as uh, the the well, first of course, the complexity of the problem. Second is the scope of the program; it become larger. Third will be you cannot really uh, make sure one particular solution will be the best for every condition. And therefore, there are a lot of techniques to be explored. One of them is to see the optimization problem as some things that you could somehow simulate. Okay, use simulations. There where we meet about hey, we can use simulation tools to solve those problems with uncertainty. Okay, so there we explore there several types of simulations in the previous module. Okay, which one of them was discrete event simulations, another so-called discrete time simulation. And we put emphasis more on the discrete event simulations, where change in event would determine how you simulate the system. Okay, so now in today's section, we will try to show to you and discuss to you about how could we, using a very simple tool such as spreadsheet. You could use Google Spreadsheet, Google Sheet, Microsoft Excel spreadsheet, all of those tools to conduct discrete event simulation. Okay, so what does it mean? Okay, so basically, maybe I can directly open the slides. Yeah, here. So we're going to discuss about this. So basically, yeah, this is from chapter 2 in the books of Ben Carson, Nelson and Nicole in the discrete event simulation. So basically, can hide this part. Yeah. So basically, when we talk about simulation, discrete event simulation, it doesn't have to be very sophisticated. You don't have to like use a very sophisticated tools such as like a simulation software or I don't know, software package or like 3D model that show how things are going on in the real life. Yes, it will help with the visualization, but the main things that you want to see in a simulation is actually was several important behavior that represent by number, right? For example, if you want to simulate a queuing system, what kind of behavior you want to see or you want to understood in those particular system? Okay, let's be more detailed. In a, let's say, a bank in one city, one branch. Yeah, Alfred, you want to
Yeah.
ask that question? Yes.
Yeah. No, I think what you're trying to refer, Professor, is like if we are simulating a bank, I think the waiting time is what we would really like to know, right?
Indeed, yes. So if you are going to see the waiting time, or the queue length, or how busy is the teller, or how long, yeah, the waiting, how long the customer was waiting until they get served. Uh, if you are using simulation software package, you can, of course, it will be very beautiful. You can see one things moving to another. Let's say customer is entering the bank branches, and then they start queuing on the take like a queue, let's say queue number, and then they sit, they wait for to be called by the teller or by the customer services. It really depends on what they are doing, right? It will be very beautiful if you are using simulation software. But instead, the main things that you want to observe, it's still the essential can still be observed by a very simple tool such as Spreadsheet, because what are those waiting time? What are those um, um, uh, teller usage? Like how busy was the teller? Can be represented in number, right? So therefore, today we would like to explore how simulations, uh, even like more advanced simulations, could be simulated using a very simple tool such as Spreadsheet. Okay, so so therefore, here things that we would like to start by discussing the outline. We do have like simulations normally would carry out several steps, right? We discussed about this in the last meeting. There are several steps of understanding or getting the most out of the simulations system that you simulate. First, of course, you want to determine what kind of an input that you will put to show the characteristics of the systems that you have. Okay. We will explore this further later on. But things that I can say about this is that input characteristics, well, you can somehow, the more input, the better you can simulate a system. Yes, but for several case, when you really know what kind of things you want to simulate in your system, Sometimes you just need to have the amount of input that is enough to represent the system characteristics. For example, earlier about the bank system, there are a lot of inputs that you can use in the banks, right? To simulate a bank system. But if your goal is just to see how the queuing process of the customer services or teller services of those banks, you just need to know the arrival times, or here we call it the inter-arrival times, the time between one arrival to another arrival of the customer to that bank, right? So determining input characteristic is a very important part of doing simulations, okay? And then for this one, since we're discussing about how to use spreadsheet, sorry, we will discuss more about how to construct so-called simulation table, because all the things that you want to simulate, you will put it into a table, right? Spreadsheet is about representing data in table form, right? What would be the column? What would be the rows? Okay. And then we will discuss on repetition. Okay. So in simulating things, because there are uncertainty involved in the simulations, you need to understood the how to use the repetitions to generate like okay, how many repetitions would be necessary to represent the system, and then uh, for each of those repetitions, you will observe the output of the simulation, in which like you have the input, which is the inter-arrival time of the customer, and then the output that you want to observe, like what Sir was mentioned it earlier, I forgot. Mohammed. Mohammed mentioning about the waiting time. Okay, if you want to observe the waiting time, then they treat those as an output. So every repetitions, okay, the first repetitions of the simulations with this type of input, uncertain, you got this type of output. This would be uncertain as well, because input, process, output, it's all connected. Okay, so then, yeah, this is the things that we will discuss also today. So, more than that, we will also discuss several examples about queuing, theory, inventory, network analysis, but if we have some time to do it. But if not, maybe I will just go through it and then like see if you need to further elaboration on it, you can talk to me in a different forums that I can create. Okay. Yeah. Now, I think one of the system that most often being simulated is somewhat or more often can be represented in a queuing system. Many systems is somewhat a variance of a queuing system. Start from simple one like the banks that I mentioned earlier. We have restaurant. Restaurant is also queuing system. Even like computer network system, it's also queuing of how you send packets data to the networks and then analyze how those data move on from one hub to another hub, data hub. Uh, what else? Yeah, many manufacturing systems, also another queuing system that could be represented in a job shop, flow shop. But basically, a queuing system we can describe as this. It will have like so-called calling populations. Okay, so populations that would provide the input to the system, and then the nature of the arrivals, the service mechanism, capacity, and the queuing discipline, like first in, first serve, or last in, first serve, and several. Okay. If you are going to see it in further detail, go to this chapter in the book. which I also give the reference to. And for learning purpose, the learning that we will do today, we will discuss about this one, so-called what a single channel queue. Okay, so what is this? A single channel queue is a queuing system where you have only one server. Okay, so when a system has one server, means that each customer that or demand or anything that represent of some things arrive based on the calling populations will queue to be served by this server. Like in the bank, if we go back to those previous example, let's say bank customer entering the bank, okay, and then we only have one teller, okay, and then when the customer is joining, they will see, oh, if there is anyone in the being served by the teller now. If yes, then you need to queue. If not, then you can go to that teller and then be served by those teller. Yeah. So those are a single channel queue. And most often it is simulated by the calling population is infinite, means that we don't really know how many total customers do we have. And then the arrival of for service occur one at a time in a random fashion. So there is no multiple arrival at the same times, okay, which maybe not represent bank. Bank can have two more customers at the same time. So, but this is a simplification of it. So once they join the waiting line, they will eventually serve. Okay. The arrival and service are defined by the distributions of the time between arrival and service time. Okay, so when the customer will arrive and then being served, it really depends whether they are still somebody else that being served by the server. If not, maybe they need to wait for them to be served. Okay, so previous customer may have so-called service time. So that will be determined how long you should wait, right? Okay, but the key concept is here. The system state is number of units in the system with the status of either they are busy or they are idle. Okay, busy means they are currently serve some customer, one customer. Idle means they are currently not serving any customer. Yeah, maybe because like when they finish serve one customer and then the inter-arrival time is quite long, then the server become idle. Okay. And then we also will be introduced to so-called simulation clock, where it used to track the simulation. Okay, next, in order to understood how you can simulate a system in a spreadsheet, you will need to also understood about how to create event lists. This will determine what will happen next. Okay, so track the future times that which has different types of event occurring in the simulation. So because we are doing discrete event simulations, so you will need to have a list of events that will going to happen. Okay, and each event will trigger the updates of several things in the simulations tables that you have. Okay. And then in simulations, we know that random is needed. Yeah, because if it is not random, why do we even bother to create a simulation? Just use a mathematical model, solve it using analytical tools. Then you go back to AOT1 tools that you have been studying. Yeah, because of randomness needed. Why? Because it would imitate the real life, okay, real life situation as much as possible. However, okay, to generate randomness in a computer system, you will need to have the way to create a random number. Okay. In this book, we are introduced with several approach, such as like there is a random digit tables, which is you can see it in the books. In this particular chapter, they have a list of random digit tables. How do we use it? I think there is explanations in the next slides. In next slides. You can also use, of course, the easier one would be, because nowadays I think almost everyone were familiar with spreadsheet. Spreadsheet itself has function to generate random number. Okay. In Excel, I still remember we have ran and then square and then bracket. It will generate a random number uniformly in a uniform distribution. We will discuss about statistical distribution also next meeting. It will create a random numbers between zero, uniformly random from 0 to 1. So can be 0.2, 0.3. Every time you call those function or execute those formula in Excel, you will get a random numbers. And in other simulation package, such as the things that we will study in this class using Arena, there is a way to trigger how to use the random numbers. Okay, like the simulation clock itself, and then if you want to create a uniform random inter-arrival time, they has the package to do it. But that would be for future discussion. But here, what you need to do, you understood that is that in simulating a queuing system using Excel or spreadsheet, you will need this ingredient, including the random number. Okay, now let's go to an illustration. Okay, this one is illustrating single channel queuing. Yeah, single channel queue. Here you can see like this is the tables that we will somehow work on in a features slide as well. There is this type of example. So here you can see that first we do have several customers. Okay. I don't know what kind of system is this. This is just an example. So we do have several type of customer. Assume that we are going to generate the time between arrival, which is so-called also inter-arrival time, generated by random die 5 times. So like 1, 2, 3, 4, 5. Why 5? We have 6 customers because the first customer is arrived at time 0. So you don't need to have the inter-arrival time. And assume that this is the first customer. And then next, you can read another, you draw another dice and then got inter-arrival time 2. So 0 plus 2, you get 2 also. Okay. The clock time or the time, the simulation clock. And then you roll another dice, you got 4. Okay. The most of this inter-arrival time would be 6 because the dice would be have 6 faces, right? 1 until 6. So 2, and then you have another inter-arrival 4. So now the clock in your simulations would be 2 plus 4, which is 6. Okay. And then next you draw another dice, got 1. 6 plus 1 is 7. Right. And move on, 7 plus 2 and 9. 9 plus 6 is 15. So means that you are if it is in minutes, then you are completing the simulation within 15 minutes. If it is in days, so 15 days, something like that. So that this is how you simulate in a single channel queuing. And then you can use like spreadsheet to create this one, right? Now another factors that also important to be observed in a queuing system is that we have so-called service time. Okay, so every time customer was entering the server, there will be, okay, of course, there is some system that can serve immediately, even no time to be just pass by and then directly go ahead. Considered to be service, just need to be passed. But most of the time, it has a queuing system would have service time in their server. Okay, and then there are several ways you may want to use to simulate. For example, okay, now the service time each customer will be like this, and then you are thinking about make it more lean, make the process better, and then you can simulate. The result will be reducing the service time by this amount. Then you can see how does it affect the whole system study. Okay. But again, you can use simulation package, or you can use like a spreadsheet like what we have here. Okay. Now, with that being with that being introduced to you, now we can have this complete package or complete table to show how well, this is called so-called simulation tables. This it's showing you the form in a format of customer-based simulation tables, where you can see which customer arrived in what time and when they will begin to be served, and then for how long, and then it's the service time, and then when the service will be end, or when they are finishing to be served by the server. Okay, this is the simulation tables that we have. Okay, okay. Now, with these tables being set up, you can somehow make the representations like this to more like easily understood the system works. Okay. For example, here, what is this graph meaning? Let's say you have customer one right here. Customer one is arrived at time 0 here. Okay, so we know that because there is no customer in the system yet, so customer the begin service time of customer number one would be immediately. Okay, means that they will go, it will go directly to the server, and then spend two units of time, and then means that they will finish at time unit time 2 in the simulation. So this is unit time 2. Okay, and then there we have another data where second customer is arrived. So here it arrived at time 2, and then we know that because the server is already idle by time 2, this customer can also be served immediately, right? So the begin service time would be 2 because it's already idle, the server at the time that this customer arrived. And then it will need like 1 unit of time, 1 unit of service time. So they will finish by 3. Okay, so this is 3. Yeah. Okay. And then next we move on to this next customer number 3, where you have the arrival time is 6. Okay, this is quite large gap compared to these two. Okay, what does it mean? Means that we know that the second customer finished service here, so they will somehow idle time. Okay, this would be idle time. Okay, the customer, the server would be idle here from time 3 up until time 1, 3, 4, 5, because this is around 6. Sorry, this is 6 here. Okay, time 6, and then the service time is 3 here. So they will finish, the server will be utilized up until time 9. Okay, where it is here. Okay. So now when we have another event occurring for customer number 4, okay, you see here, the customer number 4 is arrived at time 7. Yeah, this one. This here is 7. So what happened when customer 4 is arrived? You can see in the graph that by the time customer 4 is arriving, the server is still utilized by customer 3. Okay, this is customer 3. You can see it here. Customer 3 here. So means that when it's arrived, customer 4 will need to wait, right? Need to wait before it begin to be served. How long does it need to wait? Here you see this, right? Because the server will be fully occupied up until 9 in the unit of 9 here. Okay. So there, the customer 3 is finished being served by the server, and then customer 4 is entering the server to be served. Okay, by time 9, and then for how long? For 2 unit time, 11. So up until 11, and you see that here in the next event occurring, the customer 5 is also arriving at 9. What is happening at 9? First is that customer 3 is finished served, and then customer 4 is start being served by the server. So means that by time 9, the server is occupied by, it released the customer 3, but occupied by customer 4, right? So when customer 5 is arriving at 9, it also needs, or he or she also needs to wait. For how long? Again, here, up until it finished occupied by 11, customer 4, up until 11, unit time of 11. Yeah. There it will start to be served. Okay. For how long? For one unit of time, up until 12. Okay. And move on like that. When you have customer 6, you see that, oh, arrival time would be 15. Means that here, right, this is 15. Means that this is far further in the future. So up until 12, the customer 5 is already being finished being served. So we will have another idle. Yeah. Okay. This is so-called idle. Yeah. So so that's why I say that this is a tab. This simulation table here is enough if you have like a very simple system, especially queuing system, to be used to represent how things work in your particular case study. And this one is somewhat representative of how your customer being served, and then your server being utilized, and so on. Okay, so up until here, I think you can have a proper understanding already, right? How can you utilize a spreadsheet? So I know that I show it in the slides only, but if I ask you to create this in the Excel or Google Sheet, I'm pretty much confident you will be able to do it, right? Up until here, do you have any questions regarding the materials? None so far? Great. So I'll move on. Okay. In the simulation queue systems earlier that I show you, there are several things were uncertain. First is this one, the arrival time. Second is this one. Yeah. The rest were calculated, like the beginning of service time calculated, the times end of the service calculated. Okay, so how do you create? Now the question is, how do you create this and this random numbers, right? And there are several ways to induce random numbers. Okay, take example the first one. Okay, this one. We can use, I think this one is borrowed from the simulation random tables that we have in the books. But what does this means? Actually, it's like this. You can create a random numbers of time arrivals, let's say between 1 to 8 minutes. If you want to like have the same probability of having 1 minute, 2 minutes, or 3 minutes up until 8 minutes, you can put some probability number. Okay. We'll talk about probability a little bit later on, but if you want to go in the more deep, you go take the statistics class. But probability is about, in this case, is about how much of a chance this number would be used as the time between arrival. Okay. So if you give like 1 divided by 8, which is 0.125, means that you have the same probability for each time between arrival to be selected. 1 will be have 12.5% probability, 7 will have 12.5%. Okay. And cumulative probability is what? Is the cumulative number of one probability plus another probability. So here 250 means that 12.5%, 0.125 plus 0.125 here. Okay, you got this number. And then you do the same thing, okay, the rest of it. And then therefore the cumulative probability will be always equals to 1. Okay. Because yeah, probability, it's like the most the total probability of all the events will be equals to 100%, right? And here, how can you use it? How can you create it? In Spreadsheet, you can like create these tables, and then if you have, you can generate random number. So from, let's say, between, if you have 1 until 1000, so you have what, 0 at 1 until 1 to 5 would belong to this probability, and then you will assign this number, right? So you, in Excel, for example, you can use functions such as ran between, I don't remember, right, the exact formula, but something like this, ran between 1 until 1 to 1 comma 1000, might be like that. And then you will pick the result of this function. Maybe it falls between this or between this. So basically what do you do is that if it is between this, then you select this one as the probability, as the time between arrivals. Okay. The same thing with also the service time. Okay. How to do this? Service time here, you can see that it has the same approach. Okay. Cumulative probability, random digit of assignment. But here they play with the probability will be different for each event occurrence. Like if you want to have time arrival between, time between arrivals is 1 to 6, then you want to have different probabilities. Like, let's say this here, 0.1 is mean 10%, this one 20%, this one 30%, this one 25%. It's possible, okay? Because not every probability should be already only random. Okay, so you can use this approach. The difference is only here. where the cumulative probability will follow how many percentage they will add it based on this. So the random number between the digit should also be different range for each probability of time. Okay. So here is several way that you can generate a random probability, random numbers. But basically, this is the explanation. So to analyze the system by simulating arrivals and service of 100 customer. So so basically this is what in the books there is a discussions about simulating so-called grocery store. Okay, I do have the Excel file. I think I can share it to you, but I am not pretty sure that it was running. It's actually directly downloaded as a companions tools of the books. I can share it to you, but I'm not sure. I'm not trying it yet if it is run properly or not, because it's from the old Excel file version. Okay. So with that particular Excel simulations, you can analyze a system by simulating arrival and services of 100 customer, and then you can somehow also create a uniformly distributed random number to generate the arrival at a checkout counter. And then you can have tabular simulations with a random digits that can be converted from the random numbers. So that was in the Excel file of this example. So with that, you can create the simulations which represent the single server queuing simulations. There we will have 100 customers. You have the inter-arrival times. And then with the same methods, you can have 100 customer and its service time. Okay. And then you can plug, okay, the simulation, okay, those data into this. What are these called? This is called the simulation table. Okay. Exactly the same with the examples that I have given earlier. So you will have customer 1, and then inter-arrival start at clock 0. Inter-arrival time is none for the first one. The service time would be 4, and the time of service is 0. Waiting time in the queue is 0. Time of service is 4. Time customer spend in the system is 4. So basically this will be represent how long from the arrival up until the end of the service. Okay, so 0 until 4 minus 0 is 4. And waiting time means that how long from the arrival until it's begin to service. So this one, because arrival directly being service, then it's 0, right? But in another one, like another data points, so when it's arrived at 1, service time is 2. It begin to be served at 4. Means that there is a waiting from the arrival 1 until the begin of service. 4 minus 1 is 3, right? So here is some things that we need to pay attention as well. Okay. There is a questions. Professor, good point. I have questions. As we are on the simulation topic, what software normally we use at Mapua? Okay. Many lecturers in Mapua are using Pro model. Okay. However, myself was not very familiar with the Pro model. So I would refer you to Dean Yang, Dr. Yang, as well as Dr. Artvin Kester, if you know him, about the Pro model software. Okay. For me, here in Indonesia, we normally use arena simulations, and the concept is pretty much the same. So what I'm going to explore and give to you in this course is arena simulations, but I'm pretty much confident switching from one simulation tools, especially discrete event simulations, to another discrete event simulations is going to be uh, yeah, it's going to be a little bit difficult at the beginnings, but if you understood the concept, which is like this, those difficulties would be only on exploring how to do this in that software, right? How to, let's say like this, creating a random number in that software, how to analyze the output in that software and in this software. Only like that. The concept will be still here. Yeah, I'm sorry, I need to jump back and forth because I think slides you can read by yourself, but discussion like this, we we are very seldom have the opportunity, right? So use it. If you want to ask, please go ahead. Cut me in the middle of my explanations. That's fine. Okay. Now I'm going to go back here. Okay. This simulation table is some things that you can easily create if you have the previous ingredients, right? What kind of input that is going to be uncertain and simulate. Okay. And then at the end of the day, you will have this, and then you can analyze. Okay, what kind of observations you need to do? Perhaps this one, right? How long is the average? Or here is the total. If you want to find average, for the total divided by the number, the customer number. So you got the average. So how long the average of waiting time? How long, uh, or yeah, what is the average of the time? Sorry, this one. What is the average of the time is the customer spend in the system? So for example, this one, so means that 1.7 minutes is the average. So no, sorry, 174 divided by 100, yeah, 1.75 minutes. So it's not quite long. Okay. But this one is like 4.91 minutes. So at most the customer spend like 5 minutes in the system. Okay. And then you can also observe this one. How long is the customer or the server is being idle? What does it represent? It represents how good is the utilization of resource that you have. Okay. Okay, so yeah, here can somehow also generate the tables. I will try to send it to you as well. You can do the replication. Okay, so understanding about that means this we need to analyze it further, right? The analysis based on the Excel files that we have later on, you can do some things like this as well. You can see that, okay, about half of the customer will have to wait. However, the average waiting time is not excessive. Okay. Like previous one that I wanted that I say to you, like half of the customer needs to wait, but the waiting time may be only 1.74 minutes, right? The server does not have an undue amount of idle time. Yeah, earlier we see that maybe only 2 minutes is idle time, but the rest was that customer server is always working. Okay. How do I know that half of the customer? This is also representing it, like this one. Frequency of waiting times. Okay. Yeah, this one is 0, maybe here. Here, right? So half of the customer is this. This one is not have to wait. 46. Okay. So that would be the example. Uh, and other than that, we can also always explore what kind of important points that we would like to um, observe in the simulations table. You can observe something like this one, the average waiting time, for example. the probability of waiting, like the number of customer who needs to wait, and then the total number of customers. Okay. You can have also analysis on the probability of the idle server, means that the total of idle server, total of idle time for the server divided by total time of the simulations, like this. So 24% of the time the server is idle. So the probability is this one, right? And the probabilities of the server is busy means 1 minus this one. So 1 minus 0.24, 0.76. It means that 76% of the time in the simulations, the customer, the server is being idle. Okay. Okay. Okay, what else? Average service time. Average service time, of course, can be found by this one. Total service time divided by total number of customer. And then we have average inter-arrival times. This is generated randomly. This is generated randomly as well. Okay. Yeah. Up until here, do you have any like initial understanding already? You need to have input, which in this case, this one, time between arrival, service time. Normally the input will be random number, and then you need to have the simulation table to process the simulations. And finally, you need to understand what do you want to observe from the simulation table, which is the output. So input, process, output. Simulation, same thing for every system. What is the input? How do you simulate it? How do you process the simulation? What are the outputs you want to observe? Okay. This one, we are using a very simple tool of spreadsheet. Okay. Before we move on to the second examples, anyone would like to ask question? Okay, not yet. Okay, earlier we're discussing about a very simple simulation system that involves one server, one queuing line. So this will be called a single server simulations. Later we will be, in theory, there are several notations being used by researcher to represent common type of simulation, a common type of queuing system. Okay, but today let's just use a very intuitive wording. So that was a single server queue system. Okay. Now, when you involve more than one server, so let's say you have two server, two people as the teller counter, for example, then the simulations act differently, right? You are not only thinking about, hey, what if this server is idle? Okay, when you queue the system, okay, you will see, right? Is there any idle server? If yes, you go there. If not, then you have to wait, right? So, take example of here. I think in the book they are using another example, the so-called Able Baker call center example. Okay, the computer technical support center with 2 personnel. So you do have 2 servers. Okay, taking calls for and providing services about what their products is about. So the name is Able and Baker. Okay. The rule is simple. Whenever the more senior staff able get called, if both they will be directed to Apple because he is more senior perhaps, whenever if both are idle, able will be given the task first. I don't know, maybe if he is a senior or in practice normally because he's the junior staff. That's why, hey junior, you go ahead, something like that. But anyway, that's the setup that we create, being introduced in the rules, in the books as a rules of assignment. And the goal is to find how well the current arrangement works. Okay, what does it mean? It means like how well arrangement work could be also first is the queuing length is big, how long the customers need to wait before being served. Also, because we do have two server, how well is the utilizations of this both server, right? Okay, so those are the things that we need to observe later on. And for the input, we do need to create or generate a random variables to first arrival times between call, okay, because this is a call center, and then the service time. Okay, we do have two server, but maybe one server has different capability to serve the customer. Okay, so the service time should be random. Yeah. Even so, if it is not the same, if it is has the same capability, we need to still, I think, see the system in a real setting. Like for example, every customer may have different complaint, right? Every customer may need to be addressed different way. Therefore, the service time of a call center will always be different time to time, right? So the service time is one of the uncertain factors that we want to observe. And we will make a simulation for the first 100 callers, okay? So this is not unlimited. We do have limited customer, we assume 100 customer, okay? And the more color would be lead reliable research, but 100 is chosen for the purpose of this simulations. Okay. Okay. Again, that I can give you the Excel files, but we also can generate it manually. Okay. So I think I can show the files if necessary. Apple Banker. Okay, yeah, this one of the problems that I don't know how to unlock the what the generate child. Can we do it? Yeah, the macro. I think I need to resolve this one first. Okay, but I can send it to you. I can send it to you later on so that you can. This is the macro file. I will somehow check how can if not we can create it manually. Okay, so when you generate, of course you will create some things like wait, there is no here. Okay. You will create something similar to the single server. Oh, Microsoft block. Yeah, either way. So like this one, yeah, I know this is still not working on. Yeah, yeah, yeah. Okay. So for example, you will get to the yeah this column generating inter-arrival time, right? for each of the customer up until 100 here. Yeah, 100 customer. And then with this inter-arrival time, you will get the arrival time, right? Because time between the inter-arrival time is the arrival time. And then you can check who were available at what time. And you know that the rules is that whenever both are available, you will go for able, you chosen first. Okay. Then you choose put here who was chosen. And then how long is the service time, when it begin. Then you need to record what time is the server, you know that which one will be chosen. Let's say able will be able to finish. And then how long is the delays before able catching up. And then you know that that would be the end time, right? Then yeah, this is service completion time. And then you know that how long the caller is from the arrival up until the end time. Yeah. So how long they are in the system. Okay. You do it 100 times, then you will get some data like in the slides that we have. This one. Okay, so here will be 100 customers, right? And then you know that here 62 customers will have no delays. Means that the rest would be like 32, the 38 would have delay, which we can say further that only 12% only have like 2 minutes delay, 1 or 2 minutes. Okay. And then the rest would be the one that the largest one may be like only, how many is this? 3% was having delay more than 12. Yeah, so maybe 11 to 12 minutes. That is some things that you need to able to observe later on. Okay. Yeah, this is another explanations. Yeah, that one was the queuing systems that we are having. First was with one server, second with 2 servers. Okay. Other than that, we can also simulate so-called inventory management systems in the spreadsheet simulations. This something's different with the previous one. So in inventory, but the concept is still the same. Okay, you try to understand the characteristics of the system. You need to define what kind of input you are going to simulate, and then what kind of process which represent in the simulation table, and then what kind of output you want to observe. Same thing. But because you need to you need to simulate different system, you need to understand it better first. Yeah. For example, this one, if you are from industrial engineering or management or logistics, you may already familiar with this so-called inventory system. Inventory system basically handling about how would you determine how many stock need to be available in your inventory, and then when to reorder to fill out the stock, and then how much you need to order. Okay, there is several systems. One of them that we will study here is so-called MN. MN is a periodic type of inventory system where you will review in a n amount of time. So every n time, let's say, I don't know, maybe if it is a restaurant, the number of n may be less, like 1 day or 2 day. Every day you need to check what is the current positioning of your inventory, so-called Q1 here. And when you know that Q1 is below M, below the threshold that you want, you will need to order the amount of, sorry. When you know that, let me repeat the explanation. So every N time frame, you will observe the current level of your inventory, which is, let's say, this one. Okay. And then you need to check what the current level with the desired level, which is M. Okay. Therefore, when you see the discrepancies between this number with M, you will decide to order a quantity of Q. So that's why we have Q1 here. So when the first period checking, we know that, hey, we need Q1, amount of Q1 to reach the M level. Okay. Therefore, this can be simulated because we don't know how many inventory was being used. So we need to have like we need to check the policy of we have a policy, then we need to check how good is the performance of this policy. Yeah. So in this one, the demand is shown to be uniform over time. Okay, so you see that the declining is uniform. Okay, but in general, demands are not usually known. Demand would be something similar to inter-arrival. It need to be generated randomly. So here is some more explanations about inventory systems. So things that you want to observe, perhaps the total cost of inventory. Okay, but the cost of inventory is also associated with several things, such as carrying costs or inventory holding costs. Is a cost that associated with, if you have large inventory is actually a money that sit as a product, right, or a raw materials or something else. So holding it too much or too many will give impact also to your organization because you are carrying a lot of money, but not in terms of a fluid that you can use at any time because the form is in inventory. And moreover, it raises a risk, right? Risk of spoiled, risk of broken. So that's why you need to understood how to manage inventory better to reduce this so-called carrying stock inventory. Okay. And then in the previous slide, we also discussed about when you know that the level of inventory is below some things that you need to purchase, right? Purchasing new inventory, like adding up to your inventory, sometimes also involve costs, right? For example, procurement costs, other type of cost that is necessary. Logistics costs also cost. Every time you order, you need to have delivery, right? Logistics. And finally, you need to also have something like what happen if I don't have any inventory? That will be better, right? We will not have this one, not have this both costs. But the drawbacks of that is that you may lose some potential customer, right? So this is called opportunity cost, and in this case, cost that not fulfilling order because you don't have the inventory, so it has a shortage cost. Then you know that what kind of things you want to observe and what kind of things you can generate randomly. Okay, and here we do have the explanations or the example. I think there is another Excel file to it. so-called a news dealer example. So this is a classic inventory problems which concern of purchasing and sale of newspaper. Okay. So in this example, you act as a news stand. Okay, news stand means like you sell uh, uh, newspaper to customer, and then um, I know that nowadays we don't deal with newspaper anymore. Everything is digital, but assume that we still have the hard copy physical newspaper. So newspaper stands buy those hard copy of newspaper by 33 cents each, and then sell them for 50, right? Okay, so this is all assumptions. We're playing with numbers here. So means that there is 17 cents margin, right? If you are able to sell this newspaper in the market. Okay. However, there is a potential where your newspaper would not be sold, right? Or we call it a scrap, right? Some things that newspaper even more, right? If you have the physical products, because let's say it's a daily products, you sell newspaper tomorrow, uh, what you sell today, the news is already out of date, right? So this is a called scrap product. If it is unsold, you can sell it by 5 cents, for example. So you need to make a decision how much of an inventory would you consider with this setup. And furthermore, you cannot buy only one. It needs to be purchased in a bundle of 10. So you can buy 10, 20, 50, 60. Therefore, you need to identify what kind of random variables you will have, like types of the news days. Well, sometimes it's a good day where everyone buy newspaper, or it's not a rainy day. Rainy day, very, very seldom people buy hard copy newspaper. And the demand itself. Okay. Okay. Now, first of all, the output. The output that you want to observe may be more to the profit. Profit is generated from revenue from the sales minus the cost of the newspaper minus lost profit from excess demand plus salvage. Okay, salvage of sale of a scrap paper. Okay. Then with this information, you can create this, like the same, right? Generating the input, whether it's a good day, fair day, poor day, to represent what kind of how many type of demands would be generated. For a good day, if it is good, you have this one. The demand could be like the demand, you can see that for a good day, the probability of selling, okay, cumulative probability, the probability of selling more demand here is higher compared to the fair day here. Okay. Compared to even poor day, the probability of selling many newspaper would be so less, but probability of having demand of a low demand is more, right? So that's the type of the types of how the types of news days is relate with the number of demand of newspaper in this case. Okay. So after that, you can do the simulations. First of all, of course, you need to have this one, random digits of the type newsday. Then you will decide what type of newsday is here. Is it fair? Is it good? Is it poor? Okay. And then you generate the demand. The demand based on the probability of this one, fair, good, or poor. Okay. And then you need to generate, okay, you need to create a decisions how many newspaper you are going to purchase. Let's say in this case, if you somehow decide to purchase 70 newspaper every day, means that when the demand is 80, you are somehow lost sale. Okay. Okay, lost profit. Okay. 10 multiplied by 1 point, sorry, the lost profit is this one. If I'm not mistaken, 0.7 or something. Yeah, this one. 0.17. So 10 multiplied by 1.7, 0.17. So $1.7 lost profit from excess demand. Okay. And revenue sales is like 70 multiplied by because we only have 70 newspaper, right? Multiplied by the price of the newspaper is 5. 70 multiplied by 5, you got this one. Okay. Because you only stock 70, which is less than 80, the demand, so you don't have any scrap. Means that the profit is, okay, 35 minus, okay, minus what? Minus what is here? The price of the newspaper, 33. Okay, then you will get this one, 10.2. This is for a fair day. But for a good day, okay, 80, because you are doing only the same thing, 70, so you got the same profit. Okay. However, for a good day that you have predict the right demand, you are not lost any sales. So your profit is increased a little bit. Okay. However, for let's say a fair day where your demand is only 50, so you got 20 scrap paper, newspaper. So 20 multiplied by what? 5 cents, right? Earlier. So you got $1 as the surface from scrap. So the daily profit is 25 minus the what? The products that you have purchased, okay, plus the surface scrap. So this is the daily profits. Sometimes for a poor day, you can even get minus negative L. Okay, so this is the way you create the random tables, simulation tables, and then you can observe the average profit, the average revenue, the profit excess the demands, the surface scrap, and stuff. Okay, with the input of these two variables. Okay, now with these tables, you can play along, right? Let's say for if you do the 400 trials for 20 days, for example, then you can get the average daily profit was spreading like a normal distributions. So you will have like the average total credit, which is here. Sometimes 1.37.61. And 45 out of the 400 has the profit more than 160. This one. Yeah. So normally it will be between this. Okay. Next. Yeah. So that was some things that I think with if you have a ability to fix those Excel macro, um, you will able to play along with this example. Okay. Yeah. So with that example being explained, I guess like what are the things that you can see here? First of all, if you want to simulate system, things that you need to understand, of course, first, what is the goals that you want to do with the system simulation? Based on that, you can somehow simplify a little bit on the software, like what kind of input you are using. Let's say one input, like inter-arrival times for the queuing system, the demands for the inventory, as well as finally for the newspaper earlier, yeah, the demands as well, the types of the demands. So understanding what input and the characteristics that could help you represent the system. And then you need to create the simulation tables, right? Which unfortunately I can show it today. I cannot solve how to fix those macro. Um, but again, you can always create it by yourself. Uh, and also you need to know what kind of output you want to observe at the end of the simulation. There you can have like replications several times so that you can have confidence on deciding this would be the outputs that generated that you can use as an insight generated by simulations that you have. Of course, to determining how many simulations, how many replications is needed, there will be a discussion on that. But for now, at least you can see that, okay, there is a simple way to do simulation using only tools like Spreadsheet. Okay. That would be the end of the discussions, meetings that we have today. I would like to encourage again, if you have some times, go ahead to check your Blackboard and then see the quizzes. Share the quizzes and then start working on it. Okay. Okay, any questions from the students? None? Yep. So yeah, please go to observe again, check again. I hope you will be like able to catch up. Again, the quiz is not that difficult. It's just to check your understanding about the module. Okay. If that's the case, I would like to thank you again, everyone, for attending our second meeting. Let's hope you will be able to finish the materials, the quizzes in time. But again, if you have any difficulties, feel free to reach me out. Okay. Thank you very much. Good evening, everyone. Bye bye.
Thank you, Dok.